Hello students, welcome to Sai Niketan online digital classes. Today I am going to discuss PU1 chemistry, third chapter, classification of elements and periodicity in properties. In this chapter, topic is ionization enthalpy or ionization potential. It is also known as ionization energy. Suppose if we consider an atom, every atom has a nucleus at its center and electrons are revolved around the nucleus. These are the electrons revolved around the nucleus. Like this, electrons are revolved around the nucleus, and this nucleus has a positive charge and electrons have negative charge. Between electrons and positively charged nucleus, some attraction forces are present. Like this, attraction forces are exist between negatively charged electrons and positively charged nucleus. Now, if we supply some amount of energy to this atom, then these electrons can jump excited from lower energy level to higher energy level. Suppose it is the vacancy shell. By supplying some amount of energy, this electron can jump from this energy level to this energy level. Now, electron is revolving in this shell. Initially, suppose you supplied 10 electron volts energy, then second time you can supply the amount of energy is 15 electron volts. In this case, again this electron can excited from lower energy level to higher energy level. Now, this electron is jumps from this level to this level, like that. On supplying energy continuously, at a certain amount of energy, electron is completely removed from the atom. Suppose next time we have to supply 35 electron volts energy. In this case, electron is completely removed from the atom. Now, this amount of energy is called as ionization enthalpy. Definition: the minimum amount of energy required for the removal of an electron from neutral isolated gaseous atom is called as ionization enthalpy. Suppose initially we have taken a neutral atom, it is a neutral, there is no charge on it, and it is the isolated single one present in a gaseous state. It is denoted by M. It is a neutral isolated gaseous atom. by supplying some amount of energy, electron completely removed from the atom, then that amount of energy is called as ionization enthalpy. After removing one electron, that neutral atom gets one positive charge because one electron is removed. Electron has a negative charge. By removing one electron, this M atom gets 1 unit of positive charge. For that removal of electron, we have to supply the some amount of energy. So here delta IH is equal to plus some x kilojoules mole inverse. Why we have to supply some amount of energy for the removal of electron? Because this positively charged nucleus strongly hold the electrons, because electrons have negative charge. Between positive charge and negative charge, attraction forces are exist. Thus some amount of energy is required for the breakdown the attraction forces. For the breakdown the attraction forces present between positively charged nucleus and valency electrons, we have to supply some amount of energy. By using this energy, we have to break down the attraction forces present between positively charged nucleus and negatively charged electrons. That's why after breaking attraction forces, then electron is completely removed. Means for the removal of this electron, some amount of energy is required. How much amount of energy is required for the removal of electron from neutral isolated gaseous atom? That amount of energy is called as ionization enthalpy. Ionization enthalpy is denoted by delta IH or IE, ionization enthalpy, or IP means ionization potential. In general, it is like a pass mark for a student. What is meant by pass mark? Suppose a student studying 10th standard. To promote this student A from 10th to PU1 or 11th standard, he should get pass mark minimum, suppose 35%. Okay. If he got 35% marks in all subjects, then that student promote from 10th standard to 11th standard. So this much marks is called as, these are the minimum marks to promote a student from lower class to higher class. Then it is called as a passing mark. Is it clear? Similarly, it is also some minimum amount of energy for the removal of electron from isolated neutral gaseous atom. Okay. Suppose in this case, initially we have taken a atom, at center positive charge is there. In valence shell, valence electrons, outermost electrons are revolved around the nucleus. Between positive charge and negative charge electron, attraction forces are present. And this atom contains so many vacant shells like this. And by supplying initially 10 electron volts energy, electron can jump from lower energy to higher energy here. And by supplying 15 electron volts energy, then electron again jumps from lower energy to higher energy. Again, if you supplied 30 electron volts energy, still electron is within the atom only, but it is excited from lower energy level to higher energy level. And by supplying 34 electron volts energy, again still it is in atom only, but it is excited to higher energy level. Suppose it is higher energy level, now it is moving in next level. But when we supply 35 electron volts energy, in this case, so attraction forces present between nucleus and this outermost electron completely broken when we supply the 35 electron volts energy. Means by using 35 electron volts energy, completely we broken the attraction forces present between valency electron and nucleus. Now this electron is completely removed from the atom. Thus this minimum amount of energy is called as ionization enthalpy. Of course, if you supplied 90 electron volts energy directly instead of supplying 35 electron volts energy, then electron is completely removed. Okay, but here ionization potential means 35 electron volts only, because this much energy is enough for the breaking the attraction forces. That's why how much energy is required for the breaking the attraction forces present between nucleus and valence electrons, that much amount of energy is called as ionization enthalpy. Suppose take this previous example. In this case, student A, okay, promoted to 10th standard to 11th standard by getting 35% marks. Suppose he got 90%, then in this case also he promoted from 10th standard to 11th standard. Or another student B is there, he got 80%, he also got promoted from 10th standard to 11th standard. And another student is there, C, if he got 35%, he also promoted to 10th standard to 11th standard. Okay, but how much marks are required for the promotion of one student from lower standard to higher standard? Minimum marks, how much? 35%. So 35%, this marks only called as a passing mark, but not to 90 or 80. Is it clear? So passing mark means minimum marks required for the promotion of a student from lower standard to higher standard. Similarly, here also ionization enthalpy means it is the minimum amount. It is the minimum amount of energy required for the removal of an electron from neutral isolated gaseous atom is called as ionization enthalpy. In this case, if you supplied 60 electron volts energy, then electron is removed. But is it minimum amount? No. How much is minimum amount? 35 electron volts energy. This amount of energy is called as ionization enthalpy, but not 60 electron volts or 90 electron volts. Is it clear? Okay. Thus, what is the definition? The minimum amount of energy required for the removal of an electron from neutral isolated gaseous atom is called as ionization enthalpy, and it is denoted by delta IH or IE or IP. Now units of ionization enthalpy. So ionization enthalpy nothing but it is the amount of energy. So what are the units for energy? Same units for ionization enthalpy. It is expressed in electron volts per atom or kilojoules per mole. Next, factors affecting ionization enthalpy. Here 5 factors are affect the ionization enthalpy value. In this one, first one is size or radius of atom. Second one is effective nuclear charge. Or magnitude of nuclear charge. Third one is shielding effect or screening effect. Fourth one is penetration ability or penetration power of s orbital, p orbital, d orbital and f orbitals. And fifth one is stability. It is in terms of electronic configuration. So this is based on stability, or you can take it as electronic configuration. These are the factors affecting ionization enthalpy. What are they? Size or radius of atom, effective nuclear charge or magnitude of nuclear charge. Third one is the shielding effect or screening effect, and fourth one is the penetration ability or penetration power of s, p, d and f orbitals. Last one is stability of that atom or electronic configuration of that atom. These are the factors affecting. One by one we will discuss. First one is the size or radius of an atom. First factor is size or radius of atom. Keep in one point in your mind, this ionization enthalpy is directly proportional to attractive forces present between nucleus and outermost electron. Because strong attraction forces are present between nucleus and outer electron, then we have to supply more amount of energy to break down that attractive forces. So that is nothing but ionization enthalpy. Suppose an atom with large size, bigger size atom, this one. Here nucleus is there, positive charge, and one electron is revolved around the nucleus. Then attraction forces are present between positively charged nucleus and negatively charged electron. Let it be atom A. I am taking another atom B with small size. It is also has a nucleus at its center. It is B atom. In this also valence electron or outermost electron is revolved around the nucleus. So attraction forces are present between positively charged nucleus and negatively charged electron. So this is the nucleus. It is also nucleus. Now, which atom requires more amount of energy for the removal of atom or breaking down the attraction forces present between nucleus and electron? Large size atom only, because size is more, then distance between a nucleus and a negatively charged electron is more. When the distance is more, then attraction forces are weak. Thus atom A has less attractive forces. Means this nucleus less hold this electron, weakly held by the nucleus, because distance is more compared to atom B. Thus here attraction forces are less, that's why less amount of energy is enough for the breakdown the attraction forces present between a positively charged nucleus and electron. But in case of B, distance is very less, means this nucleus strongly hold the outermost electron. That means B has more attractive forces. Between a nucleus and a electron. That's why it is strongly hold the electron. For the breaking the attraction forces present between nucleus and this electron, it required a high amount of energy. Thus B required more amount of energy, but A required less amount of energy for the removal of electron. Means what is the relationship between ionization enthalpy and this size of atom? A is a large size with more size, required less amount of energy, means it has a less ionization enthalpy. In second case, B is in small size. Size is less, but it required more amount of energy. That means it has more ionization enthalpy. Thus, the relationship between ionization enthalpy and size of atom is inversely proportional to each other. Thus, an atom with a small size required more amount of energy for the removal of electron. That means any atom with a small size, it has a more ionization enthalpy. If any atom with a large size or a high radius, it has a less ionization enthalpy. Thus, ionization enthalpy is inversely proportional to size of the atom. This is the relationship between ionization enthalpy and size of atom. Example. Suppose in group 1 elements, lithium, sodium, potassium, rubidium, cesium, like that are there. Suppose consider the elements lithium, sodium, potassium. Electron configuration is 1s2, 2s1. For sodium, neon, 3s1. For potassium, argon, 4s1. Similarly, for lithium, it is a helium, 2s1. Now, lithium has how many shells? 2 shells. Only 2 shells. First shell and second shell. Sodium has how many shells? 3 shells. 1, 2, 3. And potassium has how many shells? 4 shells are there for potassium. I am writing here. Potassium 1, 2, 3 and 4. Now, valence electron is in a second shell. This is the valence electron. It is the valence electron. It is the valence electron in potassium, 4s1. Attraction forces are present between positively charged nucleus and negatively charged electrons. With a small size, strong attraction forces are present. That's why it required more ionization enthalpy. Sodium, it is a bigger size than lithium. Hence, it has a less ionization enthalpy than lithium. And potassium, again size is increases. When the size is increasing, then ionization enthalpy is decreasing because attraction forces are decreasing. Okay. Thus, size is increasing, then ionization enthalpy is decreasing. So, this is the size factor, size of the atom. What is the relationship between them? Ionization enthalpy is inversely proportional to size of atom. Lithium has a small size and it has a more ionization enthalpy. Potassium has a larger size, hence it has a less ionization enthalpy. This is the first factor. Next, second factor is effective nuclear charge or magnitude of nuclear charge. When the effective nuclear charge is increasing, then automatically attractive forces are increasing between positively charged nucleus and negatively charged outermost electron. Suppose lithium is there. What is the electronic configuration? 1s2, 2s1. Means atomic number is 3. Means in a nucleus, what is meant by atomic number? Number of protons present in the nucleus of an atom is called as atomic number. Means how many protons are present? 3 protons. And how many neutrons are present in lithium? 4 neutrons are present. Okay. Now, nucleons means protons and nucleons, both are called as nucleons. Neutrons and protons. In this nucleus, what is the charge present in this one? Protons have positive charge and neutrons are neutral, no charge. Means if you take a lithium, this is the nucleus of lithium, In this nucleus, 3 protons are present, 4 neutrons are present. Protons have positive charge, means what is the net charge on the nucleus? Plus 3. And in first shell, 2 electrons are revolving around the nucleus. In second shell, 1 electron is present. Here 3 protons are there, means what is the positive charge? Plus 3. Thus here attraction forces are present between positively charged nucleus and negatively charged electrons. So total positive charge is here plus 3 because 3 protons are present in the nucleus of lithium. Then take neon. What is the electronic configuration of neon? Atomic number is 10 and electron configuration is 1s2, 2s2, 2p6. How many protons are present? 10 protons are present, means in the nucleus of neon 10 protons are present, means what is the charge present on it? Plus 10. Around this nucleus, in first shell 2 electrons are revolving and in second shell 8 electrons are revolving. 8. Thus in this one, what is the positive charge total? Plus 10 in the nucleus, and electrons have negative charge. But in the case of lithium, what is the total nuclear charge? Plus 3. In which case attraction forces are more. Here in this nucleus, more attraction forces are present. When the number of protons are increasing, number of charged particles are increasing, then attraction force also increasing present between positively charged nucleus and negatively charged electrons. Here also attraction forces are present between positively charged nucleus and electrons, but this nucleus has a less charge, but in this case this nucleus has a more charge. Okay, thus when the effective nuclear charge is increasing, then attraction forces are increasing present between positively charged nucleus and outermost electron. When the attraction forces are increasing, ionization potential is also automatically increases, means ionization enthalpy is directly proportional to effective nuclear charge. Thus between lithium and neon, which has more ionization enthalpy? Neon only, because it has a more effective nuclear charge. Hence neon has more ionization enthalpy than lithium, because nuclear charge here plus 3 only, but here plus 10. Thus ionization enthalpy is directly proportional to effective nuclear charge, or ionization enthalpy is directly proportional to magnitude of nuclear charge. So effective nuclear charge is increasing, then ionization enthalpy is also increases. This is the effective nuclear charge. Next, third factor, shielding effect. Or screening effect. Shielding effect means in multi-electron atoms, suppose in D and F block elements, in D and F block elements. Suppose if you consider F block elements, then what is the general electron configuration of F block elements? N minus 2 F 1 to 14, N minus 1 D 0 R1, NS 2 is the electron configuration of F block elements. Means first 2 electrons enter into NS, and after that in n minus 1 maybe 0 or 1 electrons will be present, and remaining electrons are entering into n minus 2 f orbital. Suppose if you take lanthanides, in lanthanides 4f is filling. Already 6 in 6s 2 electrons are present. So this is the first shell, second, third, fourth, fifth, and sixth also is there. This is the sixth one. In sixth, 2 electrons are there. In fifth shell, s electrons, p electrons are there. After that, in fourth shell also is there. First shell contains only 2 electrons. So after entering ns, suppose this is the nth shell, then electrons are after that can enter in which shell? N minus 2 shell, means it is the n minus 2 shell. So here electrons are entering in f block elements. If you take a long rise, in fourth shell these are entering. Actually this nucleus has positive charge and electrons have negative charge. Between them attraction forces are present between these two, and between this electron and nucleus also attraction forces are present, because these electrons have negative charge, nucleus has a positive charge. But between negative charge and this negative charge electrons, repulsions are created. When the more number of electrons are entering inner shells, here number of electrons are increasing, then repulsions are increasing between inner electrons and outer electrons, because all are electrons only, they have negative charge only. Here negative charge is there, for this also negative charge is there. Thus between negative charge particles repulsions are created. Between these two, these are the repulsions. So due to the more number of electrons entering inner shell, here number of electrons are increasing. As the result, repulsions are increasing between these two electrons. Then automatically attraction forces present between positive charge nucleus and outermost electron is decreasing. Here attraction forces are increasing, and here attraction forces are decreasing between this nucleus and this electron, because these repulsions are dominating than attraction forces. Okay, that means inner electrons are acts as a screen between positively charged nucleus and negatively charged electrons. So it is called as a screening effect or a shielding effect. That means attraction forces are decreasing between positively charged nucleus and negatively charged outermost electron, due to the increasing the number of electrons in inner shell, result in the increasing the repulsions between electrons present in inner shells and electrons present in outer shells is called as a screening effect. That means inner electrons are acts as a screen between valence electrons and nucleus. It is also called as a shielding effect or a screening effect. If it is more, shielding effect is more, means repulsions are more, attraction forces are very less. So in that case required very less amount of energy. So relationship between ionization enthalpy and screening effect is inversely proportional to each other. When the repulsions are increasing, here repulsions are increasing by increasing the number of inner electrons, then attraction forces are automatically decrease. It is nothing but more screening effect is observed. When the more screening effect is there, very less attraction forces are there. When the less attraction forces are present, it required very less amount of energy for the removal of outermost electron. That means that amount is nothing but ionization enthalpy. Thus what is the relationship between ionization enthalpy? Ionization enthalpy is inversely proportional to screening effect. If screening effect is more, it has less ionization enthalpy. If screening effect is less, then it has more ionization enthalpy. Both are inversely proportional to each other. This is the screening effect or shielding effect factor. Next factor is penetration power or penetration ability of s, p, d and f orbitals. It is nothing but closeness of orbitals to nucleus. If any orbital is closer to the nucleus, then attraction forces are more between a nucleus and that orbital. So penetration ability order is S, means s orbital is in a spherical shape, that's why it is very closer to the nucleus. Hence penetration ability of s orbital is more than p orbitals. P orbitals are more penetrate than d orbitals. D orbitals are more penetrate than f orbitals. Suppose you can take 4s and 4p, 4d and 4f. In each orbital one electron is there. In this case s orbital is very closer to the nucleus. So this is the 4s orbital, let it be, one electron is there. So when the closeness is increasing, then attraction forces are more. When the attraction forces are more, it requires more amount of energy to remove this electron, means ionization enthalpy is more. Otherwise you can take 4p, it is long than 4s orbital, okay, means attraction forces are less in 4p. When the attraction forces are less, then amount of energy required for the removal of this electron is less only. Then if any electron is present in 4d, it is more far distance than 4p, then attraction force are again decreases. Then when the attraction force are decreasing, then it required less amount of energy, and 4f is more far than 4d orbitals. Then attraction force are decreasing, then ionization enthalpy is decreasing. Thus which electron requires more amount of energy? 4s electron than 4p. It requires more energy than 4d. It requires more amount energy of that 4f orbital, because it is the closeness or penetration ability of orbitals order. So it follows the same order, that is ionization enthalpy order also same only. When the orbital is closer to the nucleus, attraction forces are more. When the attraction forces are more, then it requires more amount of energy. So this is the penetration power ability of different orbitals, s, p, d and f orbitals. Another factor is electronic configuration. So electronic configuration, off filled or completely filled electron configuration have stability. Off filled or completely filled electron configuration are more stable. When the stability is attained by atom, it is very difficult to remove of electron. So in such cases they have high ionization potential. In this case they have more ionization enthalpy values. Suppose take nitrogen and oxygen. What is the electron configuration of nitrogen? It is 1s2, 2s2, 2p3. In p orbitals, off filled electron configuration is observed, 1 electron, here 1 electron, 1 electron. But in the case of oxygen, electron configuration is 1s2, 2s2, 2p4. In this case, in p orbitals, neither off filled nor completely filled electron configuration observed. This is the off filled electron configuration. Here there is no off filled or completely filled. Thus which one is more stable? Nitrogen is more stable. So stability is increasing, means removal of electron is also difficult. That's why nitrogen has more ionization enthalpy than oxygen, because it is neither off filled nor completely filled electronic configuration, but nitrogen has completely filled electron configuration. That's why it has more ionization enthalpy. Similarly, fluorine and neon. In this case, fluorine 1s2, 2s2, 2p, 5. Fluorine has neither completely nor half-filled electron configuration, but neon completely filled electron configuration is absurd. Thus, it has more stability. That's why it required more amount of energy for the removal of one electron. So this is the completely filled electronic configuration. It is neither completely filled nor half-filled. That's why neon has more ionization enthalpy than fluorine. So it has greater ionization enthalpy than fluorine because it is a stable electronic configuration, completely filled electronic configuration. Okay, this is the electronic configuration. It affects the ionization enthalpy. Actually, oxygen is in small size. Nitrogen is a little bit bigger size than oxygen, but it has actually it has more ionization enthalpy. But due to the electronic configuration, half-filled electron configuration, nitrogen has more ionization enthalpy than oxygen. Thus, atoms with half-filled or completely filled electron configuration, they are more stable. That's why they have more ionization enthalpy. Okay. Thank you.